All right, y'all. So 3.7 deals with systems of inequalities. And we'll be looking at what we call linear inequalities. Which means these will be straight lines, okay? Now remember, inequalities, when I talk about inequalities, I'm talking about greater than, less than, greater than or equals, less than or equals. And y'all, since these are inequalities, there can be more than one solution. So the solution to a linear inequality are all ordered pairs that make the inequality true. And so what we'll do, we're going to graph these, and the solutions will be the regions that we're going to shade. Anything that we shade will make this a true statement. If it's not shaded, then it will make it a false statement. So in order to graph them, we got to know a few things. So the first thing is, what kind of line will I draw? Because if we use a solid line, that means that the answers on the line make it true. If we use a dotted line, that means the answers on the line make it false. So if it's greater than or equal or less than or equal, so if it's got equals in it, we're going to use a solid line. If it's greater than or less than, if it does not have equals on it, then we will use a dashed line. Now, when you're doing these in MATLAB will have a little icon up there with a solid line and a dotted line on it. In MATLAB, by default, it's on the solid line. So if you need a dotted line, you need to click that so that it changes your line into a dotted line, okay? So that's how I determine what line I use. Equals are in it, I use a solid line. If there's no equals, we'll use a dashed line. Now to determine where we're going to shade the graphs. If it is greater than or equals or greater than. So if it's greater than, we're going to shade above the line.
Okay.
Because remember, the y values get greater as we go up, which means if it's less than or equal or less than, we will shade below the line. Now, when you got to do the shading in MATLAB, they're going to have a little paint can looking thing. You click that paint can in MATLAB and drag it to the section you want to shade. When you let go, it'll shade it all in yellow for you. All right, so that's the main thing I'm going to be looking at. What kind of line do I need? Where do I need to shade these? The rest of this, we're just going to solve them like we would if the inequality was an equal sign. We're going to solve them, plot our points, and then we'll figure out the line and the shading. So these will say graph the inequality. In a plane. So basically, they just want us to shade our answers on our graph, okay? So the first one has y is greater than x minus 4. So treat it like it's an equal sign, okay? Whatever you would do to solve them, you would do with this, just like you would with that with an equal sign. This is already solved for the y, so I'm going to find me 2 points. Once I got my 2 points, we'll graph it over here. So to keep my graph small, I'm going to pick x values of, say, 0. And then any other number I can subtract 4 from. So I'll just use 0 and 1. So what we would do first, put a 0 into that x. And then 0 minus 4 would give us a -4. So when I plug the values in, I'm just coming down here and going. I'm using equal signs, okay, just when I'm plugging my numbers in. Now let me plug a 1 in. And y'all, 1 minus 4 gives me a -3. So when x is 1, y is -3. So I got 2 points, 0, -4, 1, -3. So let's go plot our points. So here's 0, go down to -4. My next point was 1, -3, so go right to 1 and down 3. So this is greater than, it has no equals on it. So the first thing I'm gonna do is figure out my line. So I'm looking up here, and for greater than or less than, I use a dotted line. So we're gonna make our line dotted. Which means any point on the line at the moment does not make it true because it's not equals and it's not a solid line. So now, greater than, let's go to the shading. Greater than, if it's greater than or equals or greater than, we shade above the line. So above my line would be shading up here. So any point you pick in the shaded area, when you plug those x and y values in, will make that true. And I'll show you, I'll check this point right here. The center of that graph, that point is 0, 0. So let me put a 0 in for my y, greater than, a 0 for my x, -4. So this gives me 0 greater than -4, which is true. So since that's true, that sort of lets me know that I shaded the right area. So y'all, let me show you that on the calculator. So I'm gonna go click to my calculator app. All right, so what I would do, now I'll show you this both ways. This is the older calculators that do not have the color enhancement. First thing I'm gonna do is put in my equation, x -4. Now that'll graph the line, but I want it to shade for me. Now y'all, the only thing sadly that it won't do is it won't make the lines dotted and solid. It's going to make every line solid on the calculator. But it will shade for us. Now to get it to shade, you're going to arrow the cursor left on the left side of the Y1. So I'm going left. Now, when you get to the left of Y1, that's going to start blinking. What you want to do is hit enter. So we're shading above, so watch what I hit. I'm going to hit enter down here until I get this triangle that looks like it's on top. That triangle right there will shade above. Now I'm going to hit enter again and show you what the shade below triangle looks like. the triangle that's on the bottom like this shades below. So I'm going to hit enter until I get it back to my triangle I need. So that's my shade above triangle. Once you got that selected, you hit graph. And it does the graph for you. So it sort of shows you where you need to shade at. And remember, if you needed points to graph, you hit second graph to get the table. And then you can plot any two of these points, okay? Now let me show y'all that the color version does it different. So I'm gonna switch to the color calculator. So let me go to y equals and clear this. All right, so you're still gonna put in your equation, which was x minus 4. Now you still cursor left. When you get on that, mine's green at the top. Now y'all won't have the triangle there. Mine did because I used it earlier. But hit enter on that. It's going to let you change the color of the line if you want to. So I can make this orange, brown, navy, light blue, yellow. I can shade whatever color I want. Arrow down until you hit where the line part is. And on line, use the left and right arrows, and you can go through all those options. So I was shading above, so I still want the triangle that looks like it's above. Arrow down and hit OK. So now it's going to shade yellow above when I hit graph. And there you go. So the color version will actually make the grass whatever color you want. The older 84s will only do it in black. All right, y'all, so let's graph another one. All right, so number 2, they want us to graph 3x minus 5y is less than or equal to a negative 20. So y'all, the trick on this one, we want to solve for the y. So that means we're going to have to move that 3x and then divide by that negative 5. So let's start out by moving the 3x. It's positive, so we're going to subtract 3x from both sides. So bring down your negative 5y. Less than or equal to. Now, negative 20 and negative 3x, they're not like terms. So I usually put my x's first. So I'm going to make that a negative 3x. And then bring down my minus 20. That way it looks like y mx plus b form, okay? Now, we're going to have to divide by negative 5. So do y'all remember what I got to do to an inequality when I divide by a negative number? Is that ringing a bell?
You have to flip the sign or
You gotta
symbol.
flip it. There you go. So that's going to make this now a greater than or equal. So flip the sign. When dividing by negative. Or better yet, how about inequality? So flip that inequality. So it was less than or equals. Now it's going to be greater than or equals. That divides, gives me y greater than or equal. And notice all these negatives dividing are going to make everything positive. And then negative 20, negative 5, give me a positive 4. All right, then you would what? Figure out your x and y table. And then we'll be able to graph that. I'm gonna go at about 10 on this one. All right, so I will still pick 0. Now remember, I got a fraction here, so I'm going to try to clear that fraction and not have to try to graph a fraction. So anytime you got a fraction being multiplied by x, make that x match that denominator. So my second x will be a 5. So if I did 0, y would equal 3/5 times 0 plus 4. So 3/5 times 0 gives me 0 plus 4, which gives me a y value of 4. So when x is 0, y is 4. All right, then I'll come in and put in my 5. So I pick that 5 because now you can divide them 5s and make that a 1. 3 times 1 is 3. Bring down my plus 4. 3 plus 4 gives me 7. So when my x is 5, my y is 7. All right, so let me start out now. The equation I'm focusing on is going to be the equation where we solved it. So let's put 0, 4. So there's 0, go up 4. 5, 7, go right 5 and up 7. So focusing on this equation that solves for y, do I want a solid line or a dotted line?
Solid.
So definitely solid because we got equals in there. Do I want to shade above or below?
Below.
But what? Now don't look at that one. You got to look at this one here. So remember my greater than, we said greater than or greater than or equal, shade above that line. Because remember the y values get greater as we go up, okay? So you would come in here, shade all that, and be done. So now I didn't pick this point this time, but I can still use it for a test point. I know since I didn't shade this, if I put a 0 into this, it's going to make it false. So watch. If I'm checking that point right there. If you put a 0 in for the y, that's got to be greater than or equal to 3/5 times 0 plus 4. Well, 3/5 times 0 is 0. 0 plus 4 is 4. So this point right here says that 0 is greater than or equal to 4, which is false. So I didn't shade that point, and that's good because it made it false. Now, if you pick any point that is in here that is shaded, let me try this point. That is 0, 10. So if I put a 10 in for the y, that's greater than or equal to 3/5 times 0 plus 4. So watch what we get. We got 10 greater than or equal to 3/5 times 0 is 0 plus 4 is 4. 10 is greater than 4, so that makes that true. So that is true. So it's got to be true in your shaded area and false in your unshaded area. All right, y'all, any questions on that? All right, so let's see what we do when we got horizontal and vertical lines. I'm going to turn this over my pages and flip them up. X greater than -4. Now you can't do this on the calculator because it's set up for y equals. But anytime you got x in a number, this is going to be a vertical line. So when you graph it, that line's got to go vertical, okay? Now, when I put a y here in a number, the y in a number makes a horizontal line. Now, here's what I do on this. When you got x is greater than -4, that's like x equals -4 when you're solving it. Y'all, no matter what, the x's all have to be -4. X's must be -4. I don't care how many y values you pick, every x will be -4. That's what creates the vertical line, okay? Now, I can pick any two y values. So pick any two y values. And to me, 0 and 1s are the easiest. So this means I got a point at -4, 0, -4, 1. You could use -4, 2, -4, 3, -4, 4. It don't matter as long as the x is -4. All right, so this one we can make smaller. So remember, Math Lab, you're going to pick whatever line you need. You're going to come over here to -4, 0, which is right on the x-axis. Then I got -4, 1, so go left 4 and up 1. All right, so first question, solid or dotted?
Dotted.
So it's going to be dotted because there's no equals. Now, here's a trick, because you can't go above and below on a vertical line, but do the x's get bigger to the right or do they get bigger to the left?
All right.
To the right. So since x is greater than -4, we would shade to the right. Which means any point you pick in here, those x values will be greater than -4. So they're not too bad. You just got to sort of play with them. All right, y is greater than or equal to a -2. Notice there's no x variable in this one. So when you get something like this, it is a horizontal line. Left to right. Now you can actually do this one on the calculator because it's a y variable, okay? So watch the graph on this one. No matter what x values you pick on this, guess what? Those y values have to be -2. So the y's must be -2. But guess what? You can pick any two x values. So I'm going to go back to 0 and 1. But remember, you can pick any two x values. You want 4 and 5 here, 4 and 10. It don't matter what your x's are, but it does matter what the y values are. And let's see, we're fairly small again. So 1, 2, 3, 4, 5. All right, so watch this. 0, -2, starting at 0, go down to -2. Then I did 1, -2, so right 1, down 2. So I've got my line going on. So y'all, would this line be solid or dotted?
Yeah, it's a solid, right?
That is definitely solid. Would you shade it above or below?
Above.
Yeah.
Oh, definitely above, because remember, greater than, the Y's are greater going up. So we would say that above. And anything we shaded will have a Y value greater than or equal to -2. So this one, the line actually makes it true because of the equals. So like at this point we just plotted with what, 1, -2. The Y value of -2 is greater than or equal to -2. All right, so remember your X's are vertical, Y's are horizontal. On the X's, they all got to be the same as the number. On the Y lines, the horizontal, the Y's all got to be the same as that number. All right, so really we were showing you how to do this so that we could actually solve a system of inequalities. So to solve a system of inequalities, and remember, these are linear inequalities. The solution is the double shaded region of the graph. Okay, so my two shades will intersect. Where they intersect, that region is the solution, and any answer in that region makes either of my equations true. And we only got to do one of these. So this one will say graph the system of inequalities. So for this one, this is like y'all's number 5. I got y is greater than or equal to x plus 1. My second equation is y is less than or equal to 1 minus x. So we'll graph the first line shaded, we'll graph the second line shaded. Where they overlap will be our solution. So let me draw my x and y real quick. So I'm going to go out 5. This one's not too big. All righty. So what I'm going to do, I'm going to make 2 tables. I'm going to make a table for the first line, and then I'll come over here and make me a table for my second line. So I'm going to do me an x and a y for each. And I'll probably use 0 and 1s for the x's on this one and this one. So y'all, let's see. We're going to put a 0 in. 0 plus 1 is 1. So when x is 0, y is 1. Then I'll put a 1 in here. When x is 1, 1 plus 1 gives me 2. So let me plot this line, and then we'll come back and play with this one. So I got 0, 1. So 0, 1 is that point right there. My second point is 1, 2. So go right 1 and up 2. So first question, do I need that to be solid or dotted?
Solid.
So that will be solid. On that line, do we want to shade that line above or below? So remember, that's greater than or equal.
Above.
Above, there you go. So we would come in and shade that one above. So now let's play up this line and see what happens. When x is 0, 1 minus 0 gives me 1. When x is 1, 1 minus 1 gives me 0. So let's see, 0, 1, that's the same point the underline had. And then 1, 0, go right 1 and stay there. On that line, do you want that one solid or dotted?
Solid.
It's gonna be solid. Do I want to shade this line above or below?
Below.
Okay, so below because it's less than. So remember, above would be above it, so I'm going to shade it below. So I'm going to go a different direction on these ones. Can you tell the double shaded area is this section right in here and then right in here? This whole section in here is double shaded, so that would be the solution on Math Lab. And I want y'all to see what Math Lab's going to give you 4 pictures: shaded on the right, shaded above, shaded below, shaded to the left. Notice R shaded to the left, so we would pick C on that one, okay? So they're only going to give you the double shaded sections on the answer for that. All right, that was 3.7. That's the last material on my first test, okay? But what I'm going to do now, so that we'll be able to review Wednesday, I'm going to give y'all 7.1. And it's not a bad section, but it'll keep us on pace. So this is 7.1 symmetry. And this is the start of test 2 material. So symmetry, y'all know what that means, right? Like the human body, one side symmetric to the other. If you cut us right down the middle, both our halves will look the same, basically. So we're going to look at symmetry on graphs. And there's 3 types of symmetry we're looking at. We're going to first look at what we call symmetric to the x-axis. And y'all, let me draw you a graph of something that is symmetric to the x-axis. So let's say I had a line going out that way and a line coming down. To be symmetric to the x-axis means that if I fold my graph over the x-axis and it lands on itself, then it's symmetric to the x-axis. So if I was to take my graph and fold it over on that x-axis, that top part would land on that bottom part. So that's what I'm talking about. So if folding along the x-axis and the graph lands on itself. That's all I do to check the X. So next, what about the Y-axis? So let's look at something that is symmetric to the y-axis. You know, I'm just going to draw a parabola. We've been graphing parabolas all year. Draw a parabola. But guess what? If I fold this graph over the y-axis, this right side will land right on top of the left side, which makes it symmetric. So it's pretty much the same rules, except replace the x with a y. So if folding along the y-axis and the graph lands on itself. Now, things that are symmetric to the y-axis, we call them even functions. And that means that their exponents are even. So remember, parabolas were the x squared graphs. So since 2 is a even exponent, this is what we call an even function. And it's also even because it is symmetric to that y-axis. All right, y'all, so there's one more, and I don't check it like I checked them two. I do something different. And this is called symmetric to the origin. Now remember, the origin is the center of the graph where the x and y's intersect. So these are trickier to draw. So let me see. I'm going to come up, cruise through the middle, and then cruise up that way. Now, y'all see how this graph looks? To be symmetric to the origin, I got to rotate my graph 180 degrees, which means flip it upside down. And guess what? It still looks the same. So look at that and watch when I turn it back over. Still looks the same. It's going uphill, left to right. When I flip it, it's going uphill, left to right. So if rotating the graph (180 degrees), which means you're basically turning it upside down, and we have the same graph. Okay, so x-axis, fold on the x, y-axis, fold on the y. Origin, you turn it upside down. Now, if it's symmetric to the origin, it is also what we call an odd function. That means they have odd exponents, okay? All right, also, let me let y'all catch up real quick. This only has 5 problems in this section. All right, so for my first 3, we're going to determine if symmetric to the x-axis, the y-axis, or the origin. All right, so let's see what I got for number 1. All right, so this one will be sort of tricky. This one comes up, down, and then here sort of does that. This side comes down and up. And then here, that sort of lines back. All right, y'all, this is on y'all. Is this one symmetric to the x-axis, the y-axis, or the origin?
Origin.
Definitely. Because if you fold it on the X, this part hits down here, it don't even hit itself. Same thing on the Y, but if you take this graph, turn it upside down, we have the same graph. So good job. So let me see what I can do on number 2. Well, these are hard to draw like that, these examples. But is this graph symmetric to the x-axis, y-axis, or the origin? What y'all think?
The y-axis.
Yeah, so if I take this graph and fold it over to y, this right side will land right on top of the left side. So that's my y-axis. All right, let me see what they got here. This one, they got me the line coming up, the line coming back. Let me let one in real quick. All right, so x-axis, y-axis, or the origin.
X-axis.
There you go. I take that top, fold it over, it lands right on itself. All right, y'all, so that's 3 of them, 2 more to go. So this 7-1, y'all knock this thing out tonight because it's not bad. It's only 5 problems. All right, determine is, check this one out. We're going to determine if even, odd, or neither. So let's see for number 4. So this one comes down and hits. This left side comes down and hits. Is that function even, odd, or neither? Any guesses?
Even.
Oh, I heard something. What I hear?
Even.
Even. There you go. Because we said, well, go to be even, it had to be symmetric to the y-axis. And if you take that and fold it over to y, it is definitely symmetric. Also, check this out. Look how many times it hits the x-axis. It hits it twice. So the number of times it hits the x-axis will also tell you whether they're even or odd. But this one is definitely even, okay? All right, so one more for y'all. Ooh, let me redraw this, and it's trickier than I can do right there. All right, so it goes up and down, down and up, and then this part starts going up. This side comes down and up and over, and then this part comes down. Is that function even or odd?
Even.
Odd.
Yeah, because remember, odd is symmetric to the origin. So y'all look how that looks, because if I take that graph, rotate it 180 degrees, I still got the same graph. Okay. So that definitely makes it odd. Also, check this out. It crosses 1, 2, 3, 4, 5 times. Since it crosses 5 times, which is an odd number,
Got it.
take it that way. All right, so that's 7-1. That's all you got to do on that is find a little symmetry and then even and odd. One problem each of those. So, questions on those? So I tried to keep it sort of mellow tonight because I want us really to focus on Wednesday night on that review, okay? So let me stop my share. We're going to do our study guide Wednesday. Now remember, that study guide counts as a quiz grade for y'all. And you can do the quiz as many times as you need. It'll keep the highest score for you. It has 25 questions on it. Wednesday, I'll show you which 5 I took off of it for my test. So I only made the test 20 questions. So hopefully you knock out that 25 question quiz. My 20 questions, I hope, are easier to get through. The test has a time limit of 90 minutes and you only get 1 attempt. So that's why I would go through that study guide until you got a good grade on it. Once you get a good grade on that, knock out that test. Now, since I was sick last Monday, the due date on the test will now be October 2nd instead of September 25th. So I wanted y'all to have time to really play with that study guide before y'all hit that test, okay? Because y'all remember the tests, they're like 50% of your grade in here, okay? And then I think the quizzes were 10, so get good on the quiz, then do the test. Now it's time for y'all's questions. What questions y'all got? So let me see.
Can you go over that? You said do the study guide and then knock the test out, and you can do the study guide as many times as you would like.
Say it again.
Can you go over that? You said do the study guide and then knock out the test,
Yeah. So
but
here's
the study,
the
okay.
study guide. Let me switch it to my writing again. So your study guide, it has 25 questions, but you can do it unlimited times. So you can do this study guide as many times as it takes until you get really comfortable with it. Once you get comfortable with that, try test 1. Now test 1, I'm only taking 20 out of those 25. It'll be 20 questions. And I'll let y'all know what 20 questions it'll be. I'm going to let y'all know Wednesday which 5 I took off of that, okay? But here's the thing, on the test, you get 1 attempt. So that's what usually people that get good grades on that study guide and then they do the test, they usually do a little better on the test. So the best preparation for this test is going to be that study guide. Now remember, you got to do the study guide because it's a quiz grade. Okay, so like 10% of y'all's score comes off of that. You got 4 quizzes, and that's the 4 study guides for this year, okay? So unlimited attempts, get good on this, come knock this out. Latasha, did that answer that?
Yes, thank you.
All right. Yeah, and then remember, we're gonna do this in class. We're gonna knock out 25 questions in class to get y'all back in shape, because we gotta go all the way back to 2-1 material, 2-2 and all of that. So we'll do all 25 of these Wednesday night. And then, your test will open Wednesday for test 1. But remember, it's not due until October 2nd. So if you don't feel comfortable by this weekend, keep practicing that study guide until you feel comfortable, and then do that test, okay? Now, we will start next Monday. We will start 7.2 and start going through the second test material, okay? But at least that way y'all can practice until you do good on that test. All right, so let me stop our recording.